Hello and welcome to part 3 of binary search tree in Python. Last 2 videos we did insertion and search. Today we're going to show you how to do delete. Let's start that now, and we'll delete based on the key. So when you delete a node in a binary search tree, you can't just simply erase the node. You have to make sure it still works. So all its pointers still have to be intact. Any node to the left of a parent node has to be smaller and has to be right if it's larger. So this is a lot more complicated. So, because say we deleted 14 and didn't do anything with the pointers, 10 wouldn't point to anything, even though 12, 20, and 19 are still there. So there's three different types of nodes, I should say. There's leaf nodes, ones with no child node, so it's empty. Those are the easiest to delete because then you can just take it out and it's done. There's ones with only one child. Also, this one I think is a little harder, but still pretty easy. What you do in this case, you take its one child and attach it to its grandparent, and then just delete the node. The third one, the most complicated one, is if it has two child nodes. I'll get into how to do that when we get there, but for now, we'll start. So delete. First, we got to get our instance node, one we traversed, and we'll set that equal to the one it is. So we already have a search function, so we'll just use that. So let's check if it's real. So if it's not null, we'll continue. Okay, so like I said, there's three different ways. So let's just get them out now. So instance node dot left and instance node dot right. I'm just gonna pass right now so I can write them out. This is if it has two children, left and a right. Instance node dot left and dot right equals none. So this is if it only has one left child in the node we're deleting. And okay, I'll type it out. Is none and okay. So that's if the right child's there. I should be doing else if, and then we'll have else, and that's if it has no children. So this is the easy one. So let's just start with that. First thing we got to find. So let's say we're deleting 19. We got to find out the relation to the parent node. So if it's the left node or the right child node of the parent node. Hopefully that makes sense. So if our instance node dot parent dot left equals our instance node, so if that's the left parent's child, I'm confusing myself. I don't know, just look at the code. Maybe that'll make sense. If not, I'm sorry. We'll set instance node dot parent dot left to be equal to none. And now there's no pointer to the node we're deleting, which is what we're going for. Else instance node dot parent dot right equals none. Makes sense? And after we get to this, let's just, now that we're here, delete the instance node. Okay. Okay, so now let's do if it has a right child but no left child. Same thing. We're going to check if it's the left child of the parent or the right. Let's just copy and paste it because it's pretty similar. But instead of having a null pointer, we'll give it the child of the instance node. Right? Okay, we can even do the same thing if it has a left child and no right child. No, we're going to the left. So in case you're wondering, let's go. So we're deleting 20 or something like that. It has a left child and no right child. So when we're deleting it, what we do is we take 19 and set it as the child node of 14. Make sense? Actually, we gotta do, we gotta set its parent. So dot left dot parent, and that equals our instance node's parent. Copy and paste this a bunch of times. No, I don't think I'm doing this right. Right. Okay. Well, hopefully that works. Okay, so last but not least, let's do what to do when we're deleting a node with two children. So we can't just find any node to replace. Say we're deleting 3. We can't just choose any of these numbers to replace it, because what if we chose 7 to go to 3? Well, then 5 would have to go in the left subtree. So there's basically 2 numbers we can choose to replace the node we're deleting with. So one, we go to the left subtree and find its largest number, or we go to the right subtree and find its smallest number. So let's go to the left subtree and find its largest number. So we keep going right, we reach 2. So we would replace this 3 with 2. And it would still work, because look, everything smaller would be 1, everything larger, everything to the right will be larger than 2. So that's what we're going to do. So let's go to this. Okay, so we're going to look for the largest node, and that's going to equal instance node dot left. Okay, and then we're just going to keep moving right, and once we reach an empty node, then we know we found the largest one. So while instance node dot right. Okay, and then what we got to do is delete the largest node, but make sure we remember it. So actually, first we got to make sure it has no children nodes. So we don't have to check if it has a right node, because if it does, it would keep going to the right. So, and then we got to find the relation it is to its parent. So if instance node dot parent dot left, show you now this is largest node. Sorry. Equals. Okay, then we'll set its child node to be the left of its current parent node. This is kind of hard to explain, so sorry. So largest node dot parent dot left will now equal its left child. So we've taken its pointer and moved it away from the largest node. Okay, we'll go else. So if it's the right child, we'll now set its right child there. Okay, now okay. Actually, you know what? This is not supposed to be that. So we're checking if it has a right one. Yeah, that's just wrong. Large. So we're going to keep moving to the right, and when there is no more right, so largest node dot right equals null, we'll continue. Okay. So let's go back here. So if it hasn't left none, we'll do this. If it doesn't, we'll just use this. And instead of setting it to anything, we'll set it to none. So now we've successfully, whoops. Okay, I'm deleting too much. Good, now we've successfully deleted our largest node. Now we have to do is put that largest node in the place of the instance node. So this is the one we're deleting. So let's just take all the information and then just transfer it directly to the largest node. So largest node left will be our largest node right, or instant node left, sorry. Largest node right will be instant node right. Can't talk right now. I'll just type right now. And we'll set the parent to okay, so now the subtree of the largest node will equal what used to be the subtree of the node we're deleting. So now all we gotta do is set its parent's pointer to be equal to the largest node instead of the instance node. So I'll have to delete the change the parent node after because I still need it. If instance node dot parent, lazy typing, instance node dot parent dot left equals instance node. So I still need the parent at this point. So, and then we'll set instance node dot parent dot left to be equal to our largest node, and then we'll get an else going in case it's on the right, and let's do that again, and then dot parent will now equal the largest node. Okay, and I think that's all we have to do for deleting two nodes. There's construction going outside. I don't know if you're hearing that through my mic, but might be some buzzing sound. Sorry about that. But back to this. So I think that's all I have to do. Let's delete 3. Actually, no. Let's go. So let's delete 9 because it has no children. 0, 1. I don't see any 9. So yes, it was deleted. Okay, now let's delete one with 1 child. Let's delete 20 and see if 19 gets deleted. Okay, 19 stayed there. It's still in there. So 20 was successfully deleted. Now, dun 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 dun. Let's see if our 2 node one. If there's a problem, it's gonna be here. So let's delete 3. It worked. So 3 is gone. 5, 7, 9, and 2 still there. So yeah, it worked perfectly. And what was the other one? I think it was 14. 14, 20, and 19 are still there. Yeah, so I think that we just deleted a node from a binary search tree. So that's all I'm going to do for today. I might do another one on balanced search trees. I don't know, I haven't decided yet, but as for now, that's the end of the video. So thanks for watching.